A very good afternoon, ladies and gentlemen. Thank you for tuning in. Hope you are having a pleasant day. It's great to be back again this week with another episode of the Strata Talk Show. With that, I would like to welcome everyone to the 43rd episode of the Strata Talk Show, brought to you by the Excel Academy of Real Estate. For those who are new viewers, in this talk show, we'll be discussing issues and cases related to the management of stratified developments with various industry professionals. Joining us today, we have Mr. Kuan You Wai, uh, who is the director of PKN Building Solutions, who will speak on the topic of damp indoor space, mold, and indoor air quality. If you have any questions for Mr. Kwan, feel free to leave them in the Facebook comment section below, which we'll address in the Q&A section at the end of this show. Without further ado, join me at welcoming Mr. Kuan Yu Wai. Welcome, sir.
Hi, good afternoon. So, okay. So I'd like to start the presentation now, shall I? Okay. Thanks for your precious time to listen to me pertaining to the critical issue of built environment, which is damp indoor space and health. So I'm actually a certified mold remediation contractor based on American standard. And also, I'm an infrared inspector, concrete repair certified professional, as well as a member to the International Concrete Repair Institute, Roof Consultant Institute, and Malaysia Institute of Material Malaysia as well, and some other professional bodies. So, beside, I also is a technical advisor for CIS 7 Construction Quality Assessment System in Malaysia, as well as the proposed Malaysia Waterproofing Standard under Jabatan Standard Malaysia. So, okay, let's look into what is mold. Actually, mold is, in layman term, you can say something like microscopic plant. Why I say plant? Because it actually behave quite like a plant, whereby it have seed known as spores, it have a trunk known as hypa, it also have root, which is also another part of the hyper. So why uh, why we can see mold but not bacteria? In fact, when the mold grow, bacteria, virus, protozoa, uh, the bed bugs, the a number of microorganisms will come to grow together. And why? What are the conditions that can make it to grow? First, it must have oxygen, which we cannot control. It must have nutrient, which also we cannot control because our skin flake as well as dust could be there. Very good nutrient. Temperature, so long that human can live, they can live. But things that we can control is the availability of water. So it need to have all these criteria before it can grow. So this is the comparison of how the size of the mold as well as bacteria. Mold is 100 to 150 times bigger than bacteria and much bigger than virus. That's why when biological contamination start, we actually see mold first, but it come in one battalion like the drawing that I draw. Underneath the uh, group mold, there could be a lot of bed bugs, could be a lot of bacteria as well as other microorganisms. So it is it is a sign of biological contamination. Biological means sesuatu yang hidup, things which is alive but at microscopic level. So in 2002, the book Damn Indoor Space and Health was published. It's actually indeed a report done by Institute of Medicine under the sponsorship of Center of Disease Control and Prevention. Because the study was done due to the public panic about black mold in the North America. in the late 90s. So as a result, Center of Disease Control triggered a very wide scale of a massive scale of research, but still the report actually stated that due to the variety of microorganisms, the report is actually insufficient. It's up to the level that for our preliminary understanding about the microscopic world, which is the biggest biomass in the earth. Okay, so in 2008, another book by the American Industrial Hygienists Association was also published. And then in 2008, the same years, America have a standard for mold remediation, professional mold remediation, which I'm trained in. And in 2009, the guideline for indoor air quality, dampness, and mold was published by World Health Organization. So this is a relatively new knowledge whereby um, probably a number of professional or designer in the building industry are not aware of. In microscopic level, it can come with different color. It can come with different pattern when it start to grow, when it start to colonize. Okay, penicillium is toxic, but penicillium can also be made as a medicine. So yeah, it has wonders, but it also meantime is a toxin by itself. And the worst are the king of all mold, the black mold, is known as Strata chatterum. The last picture in this slides. Okay, this is a summary of some study done of how some of the mold is toxic, or in another word, pathologic to us. It actually is an allergen that cause allergy to us. But some of them actually, you see in a natural ecology, whereby in the microscopic level, different mold and bacteria, they have to fight for the food. So how do they fight for the food? By emitting toxin to kill each other. And the toxin, if it come in huge volume, is equally detrimental to our health. So actually these are some of the quite common mold species in Malaysia. According to Professor Wiki of the Microbiological Department of University Malaya, she was engaged during her PhD study by ICI to develop ICI weather shield that is fungi resistant. So she was actually engaged to isolate and to identify the different type of mold. In fact, when I was trained under the American standard, I was given a list. When I show Professor Wiki about the list, she told me in Malaysia with stronger sun, with so humid environment, we actually have longer lists than the North America. So I don't know this is a good news or bad news, but the reality is as such. So okay, let's come to this. This is a summary of the report, damp indoor space and mold. And there was sufficient evidence to show that it caused upper tract respiratory allergic. Okay, it can cause coughing, wheezing, as well as asthma attack on those asthma patients. Some limited evidence or suggestive evidence that it can cause shortness of breath and some respiratory ailment. Okay, for the table one is for the condition without the presence of mold. I'm referring to escalated ambient humidity. Okay, table two actually show that in the presence of visible mold, the list is even longer, as you can read by yourself. Okay, upper respiratory tract symptom, coughing, wheezing, asthma attack, even hypersensitivity pneumonia. So okay, so these are the scientific findings. Okay, so actually in our country under Department of Occupational Safety and Health, we also have parameter for industrial as well as commercial building. Unfortunately, this is not applicable to residential. But frankly speaking, when we are sick, the old, the pregnant, the young stay at home. So those are the weaker group of our community. And by virtue of that, the parameter should even be higher because healthy people go to work. The sick and the young, they stay at home. So we ought to have higher parameter. But on the other hand, Center of Disease Control and Prevention also show that, but this is for the American setting, whereby most of the time people close the window and door. So in the event of window and door not having the natural ventilation, 49% of children with mold at home will contract asthma, and 39% of them will contract nasal allergy. In Malaysia, we also UPM work with a group from Sweden, and we discover on in general our mold and our bacteria is higher than the one in Sweden as compared to Sweden. Let's say daycare center as compared to daycare center in Sweden, our daycare center and their daycare center, we have much higher more colonization or settlement naturally in our environment. Okay, so uh, we need to go. I'm explaining about more in detail about why it happened. Okay, four important criteria: oxygen, as I mentioned, temperature, and food is something that we cannot control, except water. Water is variable. So okay, about uh, water activity is actually expressed as a ratio of vapor pressure of the air and the vapor pressure that the material interact with the vapor in the air. So it's a matter of material, how absorbing the material when it comes to vapor, as well as the amount of vapor in the air. So it is from 0 to 1. It's something like this. Pure water, we call it 1. But let's say in the same environment, if we put salt lake or salt fish, ikan masin, and then we put bread, over time we can understand that bread will grow more, much more as compared to saltfish. This is how we okay, saltfish have a lot of salt, so the osmosis effect actually prevent the mold to grow, because any water that attached to the saltfish with high level of sodium chloride, the osmosis effect cause the cell of the mold to dry up. So as a result, it cannot grow. So this is what we meant by water activity. So that's why in certain surfaces, it grow very fast, especially fabric, especially timber surface without any varnish, that they grow very fast. And their water activity is very high. And on the other hand, different species of mold need different level of water activity to grow. Some with little bit of dampness is conducive enough for them to grow. But some of them, like Strata chatrum, need very damp environment before it can grow. So this is what it meant. So, well, in the study of mold remediation that I mentioned just now, I was trained, in fact, to find dampness that more than to kill the mold, because from the American standard, mold, be it alive or dead, is equally allergenic due to the residual DNA that they left over. It's the DNA that causes to get allergic, be it alive or dead. As a result, we need to physically remove it out without cross-contamination. So at the end of the day, I was trained to find leak, and we need to understand our Malaysia environment, the way we use water, take shower, do ablution. Our built environment is much more having much moisture as compared to the let's say Europe or North America, simply because our ambient humidity, our weather cause us to sweat so easily, So and then beside domestic water, external crack line, uh, dam proving or waterproofing condensation, all this can cause our built environment to have escalated dampness that is conducive to the mold for the mold to grow. Well, water everywhere, up and down, and left and right. So how the water can penetrate into our house? Well, these are the typical location, flashing, window, external wall, even ground, especially if the ground levels look toward our building. Uh, okay, the flashing, these are the typical area that water can penetrate, especially the rainwater. With our climate change, the challenge is even bigger nowadays. So when we study water, when we analyze water, we need to know the behavior of water. Water is so volatile. It changes form, according to the pressure, the temperature, the heat, and it exists in three forms: liquid, solid, and gas, naturally in our ecology. And the way it move is it actually can penetrate through wall. It also can penetrate in some level through concrete as well as glass. It's like hantu. It can go in and out, through our environment. So it is the most adhesive non-metallic liquid, very lekat kepada permukaan. And actually, due to the adhesive nature, it actually can climb anti-gravity. You know, if the tube is small enough, if the what we call pores is small enough, and it diffuse according to the second law of thermodynamic from high concentration to low concentration. But on conversely, it also have osmosis effect. So like our concrete is actually attracting the vapor to enter it by virtue that it contains a lot of mineral like calcium carbonate, like magnesium and alumina. So when we study water, we need to study in very scientific manner. But before we can catch them, we better know the enemy. So how water behave? This is particularly true for vapor. Okay, heat flow from hot to cold, moisture flow from warm to cold, moisture flow from more to less, air flow from high temperature to low pressure, high pressure to low pressure, and gravity act down. These are the typical principles that we need to understand based on building science, particularly for vapor. Okay, so when we do inspection, we actually have to, of course, access to the site, uh, check with the occupant or the service crew, when did it happen, some historical data, observe the dripping condition, the dripping pattern. Is it consistent or is it not consistent? If it's consistent, does it have any smell? Does it have any efflorescence? Or does it have rushing water, gushing up? Or if it's not uh, consistent, does it relate to the rain? What is above the leaking spot? All this we need to check thoroughly. Then, of course, we need to look at the floor plan, look at the different plan to understand how things are designed and constructed. Check with the service crew and occupant about historical data, inspect, and if we need to do some investigative testing. For instance, flood test. For instance, pressure gauge testing. So to see if our initial understanding or in scientific term hypothesis is our hypothesis true. If it's not true, then we have to return to the site and check one more time. The whole cycle continue. I mean, start again until we get something that is that we can understand for an analysis and preparation of report. So when we go for leak detection, of course, we need to have the tool because we say sometimes, okay, water is intangible. Yeah, sometimes it is tangible, okay, due to the stain or due to the dripping water is actually sometimes tangible, but sometimes it's also intangible by virtue that it exists in our ecology in three form, depending on a number of variables. So uh, infrared, infrared or infrathermographic imager, we check surface temperature difference. Endoscope, that's what the doctor put inside my nose to check. We also use endoscope. Doctor put the thermometer into my mouth. We use moisture meter. Moisture meter harness the principle of electric. Two pins, one anode, one cathode. So if the surface have water, circuit completed, the more water, the more electric conducted, and it gives me a reading. Hygrometer is something, the equipment that we check the vapor, the percentage of vapor. Ultrasound leak detector, we detect, the doctor, they use a stethoscope. Our stethoscope in engineering for leak detection is this big. Instead of the small one used by doctor, our one is this big, like a mangkok besar. So we also check pressure. Doctor check blood pressure, we check water pressure. We can do pressure gauge testing to see if there is any leakage. And due to the nature of different type of water, we can also use a chemical manner to do chlorine tests for, let's say, seawater or domestic water, depending on the quantity, depending on the ppm. And then if groundwater, will have nitrate. So beside, we also can use a high or low voltage electronic leak detector, which I will show you later on. The rest will need the photo to explain later on. I will come to it shortly. So beside having the tool, we need to also comply to some standard, which has gone through the empirical study, which is repeatable, which has been widely recognized. For this type of method, American Society for Testing and Material, they are really good in this, because I think in North America, litigation is part of life. People sue each other every day, as I guess. Uh, so they have a lot of testing method for different building element. Let's say for toilet, ASTM-D 5957. Let's say for building external wall, ASTM-C 1060. Let's say for rooftop insulation or waterproof, C1153, and the air leakage in the indoor environment, E779. Besides, International Concrete Repair Institute also published a number of non-destructive evaluation methods, especially when it is related to concrete. And of course, American Concrete Institute have a number of guidelines on this. So here come our equipment. Our equipment, this is part of them. Actually, if nowadays, if I need to carry all my equipment out for inspection, I think I need a lorry nowadays. There are so many different equipment for different purposes. For instance, infrared imaging. Infrared imaging measure the surface temperature. So by when you go to restaurant during the MCO, the restaurant operator will not shoot you, okay, shoot with an infrared gun at one point to measure your temperature. But our infrared imager come with thousands of points. So by representing different temperature with different color, it become a mapping by itself. So we can, from the mapping, we can derive with with adequate scientific knowledge, we can derive some conclusion based on the surface temperature. But I need to alert you, in indoor environment, damp spot is some always cold, but not all cold spot are damp. For instance, if let's like what I illustrated below, from top view, if a building is blown by wind, some of the angle actually have wind gushing them at a faster speed due to aerodynamic effect. So this effect causes the edges to become colder, the two edges on top and below to become colder. The coldness, of course, if there is adequate ambient humidity or excessive ambient humidity, it can condensate easily. But it doesn't mean that it has condensated. So we need to understand the science behind heat before we can understand the science behind condensation. The science behind condensation is actually have a specific name known as psychometric science. Okay, some of the common specific heat and heat capacity. Look at all the comparison. How many energy, how many joule or how much energy is needed to increase every degree Celsius. Okay, and if you compare, water has the highest. And by virtue of water having such a high heat capacity in indoor environment, it takes longer time to warm up. In outdoor environment, because it's attached to the surface, it becomes hotter faster, as compared to brick wall and concrete. So we need to understand the nature of heat capacity before we can understand why we can use infrared imager to detect dampness. And we also need to understand, although the dampness is it need more time to get heated or cooled down, well, in due time, in sufficient time, it will become equilibrium to the environment or even become hotter than to the neighboring material. So it actually have a graph that we need to understand. Um, don't worry, I'm always here. You can look for me if you need to do leak detection. This is actually a heritage building in Jalan Pahang. So from top, we can see the torch membrane have abnormality due to the different hot and cold spot. It shows us the abnormality. We need to use a moisture meter that is what we call capacitance type that can penetrate 20 mm from the surface to confirm the water pocket. And infrared imaging at the second photo show me that the water seep into the brick wall, and I can see the blue line clearly. The third photo actually show me rising dampness, because by virtue that the blue color is concentrated at the bottom, and when we move up, you see my infrared imager, it have a box at the center. It have an arrow, right? The arrow look for the coldest spot within that small box. And if the cursor keep on pointing to the bottom, then the bottom actually having higher coldness as compared to the top. And it actually indicate rising dampness. And this is a swimming pool that I used to repair. Well, from the bottom, it looked like okay, right? But with infrared imager, we can see where are the damp spots. And to confirm it, we can use a moisture meter to verify it. Okay. And the secret of MRI of plumbing system, I actually invented this by pumping ice water into the pipe, chill water into the domestic pipe. I shouldn't pump hot water because it will melt the pipe, uh, especially those plastic pipe, not designed for hot water. So instead of hot water, I use ice water, and I use my handy pump to pump in. So if I cool down the whole pipe, I can actually see the pipe without hacking, just like the way shown in the my infrared imager here. So if there is leaking, there will be a damp patch. So if you want more info about how I do it, you can always add me in the Facebook. My identity name is capital U small y space KUAN. Okay. Moisture meter, 2 pins, one anode, one cathode. If there is any dampness on the surface, so of course we need to push this 2 pin to the surface. And if the surface is full of dampness, electric will be conducted. The higher the dampness, the more electric conducted. Is a linear equation relationship, so it's very scientific and useful. Okay, I would like to show you how I do ponding tests. Well, this is a balcony in one of the condominium in KLCC enclave. So small area, I block the drain hole and then I use uh, old newspaper covered by plastic bag to block the drain hole. So before the ponding test, I go down to the lower floor, one floor, I mean below, and I measure the moisture level before and after the ponding test. Bear in mind, American standard have guideline on this. Okay, the water level should not be more than 4 inches high, because if big quantity of water, it could be so heavy that it can cause structural crack. Secondly, of course, when you pond your water, it shouldn't enter into your living room, like this, or bedroom. And thirdly, it shouldn't also spoil your door frame, especially those door frame that made from wood. Fourthly, minimum duration of ponding test or flat test is 24 hours, not 1 hour or 2 hours. It's 24 hours minimum. It can be longer, but not shorter. Lastly, when you do ponding test, it must be attended. Okay, so when I do ponding test, I need to keep on going to measure the moisture level. And if I have sufficient evidence to say that, let's say this one is 1.4, it eventually become 1.6. Okay, I can stop my ponding test before secondary damage come. I have done a flood test which is so successful, so much water leak down, ceiling collapse. In in another case, the water even went to the DB box right under the toilet. So, in short, do not do it without regular attendance. Hygrometer have a sensor at the top or the top pit, and the sensor is sensitive to the ambient humidity, and it can cause different resistance to electric. As such, it can be used to measure ambient humidity, and ambient humidity is in the unit of relative humidity. RH in short. It tell me also dew point. Dew point is the temperature and the ambient humidity whereby condensation will happen. Okay, so in our natural ecology in Malaysia, it's between 60 to 70%. And anything higher than 70% is known as unhygienic, because it can induce the mold to grow, bacteria to grow. So beware, because our environment is naturally humid. Any increase or any leakage can become unhygienic for our health. This is what I meant by the relationship between the surface temperature and the ambient humidity, known as psychometric chart. It has been plotted in this way so that our aircon designer can use this to design the aircon system. So, but it's too deep to go in. I wish you can learn more at your own time. Endoscope. Doctor put in my nose, put in my throat. Of course, it need to be sanitized. Don't use our engineering type of probe, which is so hard and so dirty, unless you sanitize it. Don't DIY endoscopic, please. This is not meant for DIY endoscopic. So, but we slot it into the narrow space, and it's very useful, because we don't need to open so much thing. We just need to slot in the probe into the narrow space. And in this situation, the area with hidden pipe, without endoscope, I really suffer because the leaking is right behind of this hidden pipe, you know. So with endoscope, it is my work so much. Pressure gauge testing. This is a container with a pressure gauge. Of course, if you want to use it for court purpose, it needs to be calibrated. The particular pressure gauge lah. So fill in the water, connect the yellow hose to one of your point, and then shut down the stopcock for the area, the toilet or whichever area that you want to test. So in a closed loop, water is slightly compressible. So when you keep on pumping water in, the pressure will go up, 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 up. 1 bar, 2 bar, 3 bar. So I always put it as 2 bar, especially plastic pipe, because Suruhanjaya Perkhidmatan Air Negara have a guideline. Safe water pressure should be more than 1 bar, less than 3 bar. So I normally put it at 2 bar, and then lock. You see in my pump, we have pump valve. So I can use the pump valve to control, so that within the loop, my pressure gauge is inside, inside the loop to see the water pressure level. If it start to drop, then it leak. But drop of 10 to 15% is acceptable, depending on the how big is your area that you want to pressure gauge, as well as the air. The air is even more compressible than water. No? So sometimes the air will, under pressure, it will start to condensate, and the pressure will start to drop a bit, but so long that it doesn't keep on dropping, it's okay. It's acceptable based on ASTM standard, based on SPAM standard. Yeah, this is how we normally do pressure gauge testing. Let's say, if I shut down the stopcock, the stopcock for this toilet that I connected with the pressure gauge, we shut down all the stopcock except the one that connected to my gauge, and keep on pumping water. For cold water system, this is okay. But for hot water system with a water tank above the ceiling, you cannot use this equipment because the water tank have a layer of air. You just simply cannot pressurize it, So hot water, we use different method. Okay. Cold water, we can use pressure gauge testing in this manner. And this is one of the location I do my pressure gauge testing. Imagine at 12, 11 p.m., 2 bar. In 1 minute, it dropped by 0.7 bar. So naturally, it showed that, yeah, this toilet is leaking. But where is the leak? Then we pump in ice water to see the piping system without hacking. And actually, you have a wall scanner that can detect even plastic pipe. So in this case, both equipment confirm that there is a pipe and it's not leaking. And let's say if you have 10 acre, 20 acre of land estate, and somehow your groundwater is leaking, the water bill from 20 ringgit suddenly become 200. Soon it become 400, 500. So somewhere is leaking, but under the ground, how are you going to check? Some location where the pipe is embedded, especially backfill soil or infill soil or reclaimed soil, okay, the water actually will not surface, because the soil is not dense. It will go down. So in this sort of situation, the groundwater leakage will not surface to the ground surface. In this sort of situation, we use stethoscope. In our term is called ultrasonic leak detector, to detect the burst sound. Okay, burst sound, psh, burst sound. Okay, and it can measure. It can detect up to 10 feet down to the soil. Okay, I actually have this equipment and I use this type of equipment. Okay, if we can use moisture meter to detect where is the damp wall or dry wall, with the same principle, one anode and one cathode, you know, And for, let's say, single ply membrane or torch membrane, which by nature it is insulated by itself. So if there is any leakage, then there will be earthing. Okay, so this two prop where we need to spray water on the waterproof membrane for low voltage electronically detector, and we put this two prop onto the floor and start walking. And when we can sense the earthing, that is a location of leakage. Okay, that's for low voltage. For high voltage, you don't even need to spray water. The stock jump, it would jump, you know. So, but these are too expensive tool. I didn't invest on it. Okay, because to me, there are other method to check, which is cheaper and more affordable. So let's say for air leakage, you know, in some location like let's say operation theater in hospital or server room, any air leakage can bring in humid air because the surface is so cold. In the ingress of humid or untreated air can start to cause condensation. And the way to test it based on American standard is by use of blowing door fan. Uh, so we will seal up the window, or we seal up the door on what we want to test now. Okay, you want to test the window, of course we don't seal. Okay, so we seal the door and then uh, pressurize or depressurize it. So in the event of obvious difference in the air temperature outside and inside, we actually can use infrared imager to see where the air come in, you know. So like on the other hand, we also can use smoke to see how the air, does the air suck out, or you know, being sucked or being blown in. So this is some of the scientific method to measure air leakage. And I would like to bring to your attention in a case. In this case, no leakage, but full of mold. Why full of mold? Okay, you see aircon in blue color, it keep, it keep on blowing to one wall. And this wall is covered by vinyl paper or the wallpaper, plastic wallpaper. So imagine it also have a wind turbine. The wind turbine will depressurize the air inside the house, right? It will suck out the air, especially due to stack effect of hot air. It will suck out the air. So air pressure is lower than outside. Aircon actually dry up the air, have a function to dry up the air. Because the colder your surface, the drier the air. Otherwise, condensation will start to build up. And then because I'm sure you can see, we have a condensate water pipe to drain out the you know, the water that in the ambient is dry up. It actually drain out through the condensate aircon pipe. So in this type of situation, the vapor pressure is high outside, low inside. So when the pressure start to go through the wall, it's blocked by the vinyl tile, the vinyl paper, okay, vinyl wallpaper, and it started to condense it behind the vinyl wallpaper. This situation actually happened to one of my students in University Malaya. Uh, it actually happened in her house, you know. But unfortunately, I didn't have a chance to witness it. But she confirmed that it really happened in her house. So beware. You know, this thing need to have scientific understanding about vapor as well as ingress of rainwater. So when there is indoor mold growth, when you can see with naked eye mold growth, or we call it visible mold, that will be bad enough. You know, actually, the rule of thumb is if we have identified mold growth with our naked eye alone, you don't need to do any testing anymore. You need to sanitize. You need to get the pregnant, the asthma, the cancer patient, the young, the old, to out of the house, you know, and then start to check the leakage, block the leakage temporarily, do containment to prevent cross contamination, and the one who do all this must be protected by personal protection equipment. This is some of the cleanup procedure proposed by Environmental Protection Agency USA. Let's say when water start to come in within 24 hours to 48 hours, bear in mind mold will grow if persistent excessive dampness present in more than 48 hours. So let's say now in this guy, if there is more than 48 hours, let's say, if less, sorry, in this case it's less than 48 hours, you need to quickly go and dry up all your fabric. If it's more than 48 hours, you better throw it, because once the mold start to grow into your fabric is uneven and it absorbs so much of water, and it is actually the best food of mold and bacteria. So the guidelines say just throw it now. So okay, clean up for water damage for more than 48 hours. So it depends on what type of water. Let's say wastewater. Oh goodness, full of nutrient and macam-macam kuman, macam-macam germs. So the sanitization is very stringent. Okay, and then for books, for carpet, some of them need to be thrown away already. But in developed country, they have specialized cleaning for contaminated material. But so far that I know, it's not available in Malaysia because perhaps the awareness is and the demand is not there. So uh, please read through at your free time and uh, clean up method, personal protection equipment and containment. Let's say in big contaminated area, you actually need to do it very scientifically to prevent cross contamination. And I always encourage my audience as well as the victim of water ingress. After the water ingress, you actually need to sanitize the whole building, or sorry, the affected area, so that uh, especially for the water present more than 48 hours, or for the ingress of river water or dirty water or wastewater, the sanitization should be done very stringently. Okay, those who do all this must be protected by ideally minimum uh, N95
Dear viewers, I believe that Mr. Kuan is facing some difficulties with his internet connection. Please bear with us and give us a moment to bring him back. He'll be back in a short while. Thank you.
Hello. I'm sorry, just now connection problem, but it's not raining. Yeah, just telephone line. So can the moderator return me to where I stopped just now? Which slide?
I believe it was slide number 41, sir.
I think my slices is 61, 61. So I'm about to finish. This one. Can you see my slides now? So can I resume my presentation now?
Yes, sir. Please go ahead.
Okay. Okay. I resume this slide. Okay. In this small house, we have aircon. We also have vinyl tiles, vinyl wallpaper, plastic wallpaper, which is not breathable. Okay. And we also have a wind turbine. Wind turbine under hot sun, it become pulling out the hot air from the house, causing the house to have negative air pressure as compared to the outside environment. Meantime, under the hot sun and humid air, the moisture flow, and then from outside into the building. And the aircon was turned on. So this aircon keep on blowing to the wall opposite to the aircon. So the wall become cool down. So in cool surface, the vapor pressure high at outside, low in inside. The temperature high in outside, low in inside. The vapor pressure will start to move into the house. And the vapor, after going through the wall, it was entrapped under the vinyl wallpaper behind. So when the humidity no when the humidity keep on escalating and the aircon blowing on the vinyl wallpaper, condensation will happen behind the vinyl wallpaper. So as a result, no leakage, full of mold due to condensation. This actually happened in a house of my student in UC Malaya, and she confirmed this actually happened in her house. Exactly the similar situation like this. So unfortunately, I didn't have a chance to visit the house, but I can share with you when we diagnose this type of dampness, we need to have scientific understanding about how condensation can happen, how water can seep into the building. All this must be can be explained in a scientific manner, especially when we have the suitable uh, tool, diagnostic tool. So when when we can see mold with our naked eye, the rule of thumb is very bad already. We don't even need to do any petri dish sampling. We don't even need to do bacterial count, mold count. No need. This place needs sanitization already. Don't need all the tests. But sometimes we do recommend the test if you want to build up the case in a scientific manner for the litigation purpose. So in this type of situation whereby you can see with naked eye the visible mold, the old, young, pregnant, immunocompromised cancer patient, asthma patient, respiratory patient, please leave the building. Okay, please diagnose where is the leakage, stop it temporarily to do the repair work, get the affected building contained so that the mold doesn't flow into other part of the building. Those who do all this job must be protected by PPE. Okay, so okay, water clean up. In the event water go into the building, but for less than 24 hours, this is a guideline to say that quickly get all the fabric dry up as fast as possible so that mold doesn't start to grow. But in the event water stay in the building for more than 48 hours, especially uh, dirty water, let's say from the kitchen or from the waste pipe or from the river water, oh goodness, you better sanitize it maximum more because all this water carry a lot of nutrients and bacteria and mold and all type of germs. So this is some of the guidelines that I hope you can read through by yourself. And some of them, let's say the cleanup method 3, a number of them recommend throwing it out. Ha- uh, and the common thing to do when we do mold cleaning is to use HEPA vacuum cleaner that have a HEPA filter. So because HEPA filter can entrap mold and germs, depending on the grade of the HEPA filter. So and then we also need to we don't spray, okay? Because when we spray, everything is blown out, and then is things will get worse. The key is we need to understand mold, be it alive or dead, is equally allergenic due to the residual DNA. Basically, we need to wipe clean as much as possible. Don't stir it up, okay? Don't spray sanitizer because when spraying it before the sanitizer reach the surface, the air pressure will get the spores blown away. So now you get me right. A lot of people, a lot of cleaning companies just spray and spray. Every raining season, just come and spray. And after all, when the germs and mold become uh, start to mutate and immune to the sanitizer, then they become Superman. In this case, it's super germs. So those that survive the toughest condition become the Superman. Okay, so all this we need to be aware. Minimum N95. I actually use that, but I feel that it blocked my intake of oxygen. So there are some respirator that have an air pump that will make the worker feel better lah. Glove, disposable full body clothing. In the event of massive mold cleanup, you do need this. Containment, we need to block the area with a plastic sheet, which is thick enough. Install a temporary exhaust fan with HEPA filter as well, so that the area become having negative air pressure. So the negative air pressure is the air is vent out directly to the building from the building. Okay, so this is how we keep the mold contained for cleanup purpose. This is how it look like in massive scale for massive scale of mold cleanup. Uh, so the temporary ducting, which is made in plastic, and whatever moldy or contaminated material need to be double back, need to be labeled and sent to designated disposal landfill. But in Malaysia, I don't think we have this except for hospital purpose. Okay, well we have so much thing about the wrong information. Myth number 1: opening window to increase ventilation in fully air-con building. Actually, fully air-con buildings, the surface is so cold. If you open window, the untreated air will come in, then you will start to see mold everywhere. And it will typically start on metal surface. Why? I used to think the metal surface was more delicious due to, mold tend to grow there first, instead of fabric. In fact, condensation start on metal surface. That's why water start to be available on metal surface. That's why it grow on the metal surface. It's actually not because it's more delicious. ozonizer, germicidal irradiation light. Those are photocatalytic oxidation. Those are all the myths that in the lab it work very well. But ozone is a irritant to the lung. So a lot of people told me when they turn on ozonizer, they actually cannot sleep, because it actually irritate the respiratory system. Ultra UVC, ultra germicidal irradiation light. This is good in killing the germs, but it also cause skin cancer. So I have seen in one of the airport to control odor, people put up UVC light. It can control the odor in some extent, but it also kill us. So, ayo, speechless. Biocide, unless it's prescribed by professional, you don't use biocide. Simply because we do not need to live in clean room environment one. We need to live in natural ecology of not having visible mold. That mold is equally hazardous. Mold, be it live or dead, equally allergenic. Okay? Decontamination versus moisture control. A lot of people think that they need to spray this, that, to kill germs instead of repairing the leak. Well, you can kill the germs, you can clean up the place, but if the moisture persisted for 48 hours, the germs will come back. So this is the end of my presentation. Very short, hope is sweet and nice, and open for question now.
All right. Thank you, Mr. Cohen, for that talk. We can now get a sense of how alarming a contaminated space is. So we'll be moving on to the Q&A segment where you'll hopefully clarify any questions we have on today's topic. So
These
first
are
of
some
all,
of
we
the
have
reference that
Mr. Cohen. Are you there? For our first question, we have Miss Shikin Sharul. And the question is, how can I test my indoor air quality for mold and other pollutants? I believe that Mr. Kwan is having internet issues again. Please bear with us while we try to bring him back. First question we have for today.
can you hear me now?
Yes, loud and clear, sir.
Okay, I repeat my answer. In Malaysia, under Department of Occupation and Safety and Health, we have registered indoor air quality assessor with the Department of Occupation and Safety and Health. They have the correct tool and method to do the testing for you. They can also do the swab test uh, to see what will grow up in the petri dish. All they can do. So I would urge you to look for them. Uh, in the event that you need to detect the leaking source, I'm always here.
All right, thank you, sir. Moving on, we have a question from Mr. Nicholas Chong. What are some effective strategies for preventing mold growth in a damp indoor space?
In damp indoor space, rectify the dampness. Make sure you decontaminate your area, wipe correctly, dry it up correctly, return to normal ecology. We don't need to live in clean room. I always say like that. You don't need to live in operation theater environment. So rectify your building, rectify your leakage, dry up your building.
Super. Moving on, we have a question, and I believe this is the last one for today, from Miss Nazliana. What are some ways to maintain good indoor air quality on a regular basis, even if my indoor space is not currently experiencing mold or moisture problems? And how can I safely and effectively remove mold from my indoor environment?
As I always say, we don't need to live in a clean room unless I can identify visible mold. You don't need to purposely disinfect or do a mold cleanup regularly. There's no such need. You just need to maintain the cleanliness of your building to be hygienic, clean out of and then and of course look after the dampness. Because dampness alone, of course, it can cause a lot of germs to grow, the pathogen to grow. But meantime, it also can affect our varnish, our fabric, our plastic material to degrade faster. No, it will. H2O have two free radical, two free electron. These two free electron can attach to a number of our material in our built environment and start oxidation and degradation. And by way of degradation, more volatile organic compound is released. So the key of indoor air quality is actually, of course, control your moisture level, have some good level of ventilation. Ideally, open up your window for some fresh air to come in and expose your environment to the sunlight. Sunlight have ultraviolet A, which is a natural way to kill germs. So sunlight, ventilation, but provided you live in a you if you don't if you live next to highway, then the air outside could be more polluting than the inside. If you live in high industrial area like Kerteh, the air outside is worse than inside. But in general, because we have a lot of plastic material in our building, in general, our indoor air quality inside is worse than outside. That's why we need some ventilation to vent out the our air from indoor, so that we maintain some minimal level of ventilation, not compromising so much on energy efficiency. There is always an opposite direction. When we have better indoor air quality, we will have less energy efficiency. Because energy efficiency, we need to contain the air. We need to pay the electricity to cool down our air. If our air leak out, then it's like throwing out money. But meantime, we also need minimal indoor air quality to bring in some fresh air. So and we also emit CO2. Some of our equipment emits CO2 and maybe even CO, carbon monoxide. So all this, if built up, is actually hazardous to us. So as a result, yeah, as I said, ventilation, sunlight, cleanliness, and dryness, dryness, so that there's no leakage. That's the key to it.
All right.
Any
Thank you, Mr. Kwan. I believe that was our last question. So we have now reached the end of this talk show. I would like to take this opportunity to invite all of you to our upcoming CPD seminars in March. Starting with the Digital Marketing Masterclass, we are having on the 7th and 8th March. On the 18th of March, we'll be having a Residential Tenancy Act CPD seminar by Mr. Patrick Sebastian. And lastly, we have on the 25th of March, the key principles of contract law and agency law for real estate professionals by Ms. Saraswati Sherkedeo. For more information on this, you may visit our Facebook page, which is the Excel Academy of Real Estate Facebook page, as well as contact any of our sales rep down below, including myself. I'm Nafa, and I think that's it for me. Once again, I would like to thank Mr. Kwan for the talk just now, and as well as our participants for tuning in today. We hope to see you in the next one. Thank you.